Hello and welcome to The Explainer. Today, we're looking at something that pretty much powers our entire modern world, but it's going through this massive, high-speed transformation. I'm talking about the data center. And specifically, we're diving into how the buildings we make for AI are just a completely different animal than the ones we've been using for decades. It's a totally fair question, right? I mean, we've already got thousands of these data centers scattered all over the globe. Why do we have to build brand new ones just for AI? It's a question that really gets to the heart of what AI actually is and what it needs from the place it calls home. And we got some great insights on this from a recent briefing by the technology research firm Virtualization Options LLC. And let me tell you, the key differences they laid out, they're just staggering. They make it really clear that this isn't just a simple upgrade. We're talking about a completely new blueprint for what computing even looks like. So, before we even get to the fancy hardware and the cooling systems, the most basic, fundamental difference is the job itself. The work that AI does is just a whole new kind of work. And that new kind of work, it needs a whole new kind of factory to do it. Think of it this way. A traditional data center is kind of like a big, versatile corporate office building. It's built to handle a bunch of different things at once. You got your HR department, accounting, email servers, websites. It's a generalist. An AI data center, though, it's not an office building at all. It's a purpose-built supercomputer lab, engineered for one very specific, incredibly tough job: massive, massive computation. And here's what that looks like in the real world. A payroll system just chugs along predictably, right? It processes one employee record, then the next, then the next. But training a large language model, whoa, that's a whole different ballgame. We're talking about trillions of calculations all happening at the exact same time. It's this storm of parallel math, hitting thousands of processors nonstop for weeks on end. It really is the difference between a sleepy country road and a 50-lane superhighway with no off-ramps. And that superhighway brings us to this absolutely staggering number. To keep all of those processors busy and fed with data, AI data centers need about 1,000 times more internal data throughput. 1,000 times. When you're dealing with a gap that huge, it becomes crystal clear that the old blueprints just aren't going to cut it. Not even close. So if the work itself is that different, what about the machines doing all that work? Well, as you'd probably expect, the hardware inside is just as specialized. Your standard server runs on a CPU, a central processing unit. It's a jack of all trades built to be flexible. But AI isn't a general task. It's very specialized math. And for a specialist job, you need a specialist tool. That's the GPU, the graphics processing unit. Yep, the same kind of technology that makes your video games look so incredible. These things and other custom chips like Google's TPUs are the real engines of this whole AI revolution. So what is it that makes a GPU so perfect for AI? Well, a CPU has just a few really smart, powerful cores. A GPU has thousands of simpler cores, and the magic is that they all work in parallel at the same time. They even have special little bits of hardware called tensor cores that are built for the exact kind of math AI models love. You mix that together with some super fast memory, and you've got yourself an engine built for one thing: pure, raw, computational brute force. And the result of that is a level of density that just kind of bends your mind. To put it in perspective, this quote says it all. A single modern AI rack can pack more raw computing power than an entire traditional data center from just a couple of years ago that might have had hundreds of racks. That incredible density, that's the key to everything else that follows.
Because when you pack that much power into such a tiny space, you create two gigantic new problems. First, you need an absolutely staggering amount of electricity to power it. And second, you have to get rid of an incredible amount of heat.
The numbers here are just wow. A normal server rack in a traditional data center, it might draw around 10 kilowatts of power. But an AI rack, it starts at 40 kilowatts and can go all the way up to 100. That's not like just upgrading your toaster. That's like trying to plug a lightning bolt directly into your wall socket. You need a completely new electrical infrastructure, from the power grid all the way down to the chip itself. And of course, all that power becomes heat. For decades, we've just cooled data centers with cold air. But you just can't cool a 100-kilowatt rack with air. It's physically impossible. So this is forcing a really radical shift over to liquid. We're talking about direct liquid cooling, where you pump fluid through cold plates that sit right on top of the processors, or even something called immersion cooling, which is literally dunking entire servers into a bath of specialized fluid. And this isn't just some science fiction idea. Google's already doing this for its AI hardware. By dunking their servers in liquid, they used over 40% less energy on cooling. They tripled the amount of computers they could fit in the same space, and they totally eliminated the problem of chips slowing down because they got too hot. It's a complete and total game changer.
Okay, so we've got these incredibly powerful, power-hungry machines. But for them to all work together on one giant problem, they have to communicate with each other at unbelievable speeds. And this brings us to the network inside the data center.
See, in a normal data center, most of the data traffic is what we call north-south. That means data is going from a server out to a user on the internet and then back. But in an AI cluster, almost all the traffic is east-west. It's thousands of GPUs constantly chattering back and forth with each other, sharing updates, sharing calculations. The superhighway isn't for the outside world, it's an internal one. And that internal superhighway has to be ridiculously fast. A traditional server might have a 10, maybe a 40 gigabit per second connection. The GPUs in an AI cluster, they are linked up with networks running at 200, 400, or even faster speeds. Any little slowdown there means those multi-million-dollar processors are just sitting around, doing nothing, waiting for data.
So let's put it all together. You've got specialized work, specialized hardware, extreme power and cooling needs, and a private data superhighway. When you add all those pieces up, the impact on the cost, the scale, and the future of these buildings is, well, it's massive.
You can really see the difference here on every single line item. The hardware goes from CPUs to GPUs. Power density just explodes. Cooling has to go from air to liquid. The whole focus of the network shifts from talking to users to talking between GPUs. But that last line, that's the real kicker, the refresh cycle. Because AI hardware is getting better so fast, these incredibly expensive buildings become basically obsolete in just 2 to 3 years, not the 5 to 7 we're used to. The pace is just relentless. And all of that translates directly to dollars and cents. All in, building an AI-ready data center can be anywhere from 3 to 10 times more expensive per square foot. That's a monumental investment in power, in cooling, in networking, and it isn't just an engineering challenge anymore. It's completely reshaping the economics of the entire tech industry. So it's pretty obvious we can't just run AI in the old data centers. These new facilities are much more like particle accelerators than they are like office parks. And this all leaves us with a really critical question for the future. As this technology becomes essential for everything, for science, for business, for society, the challenge isn't just going to be building these things. It's going to be figuring out how we power and cool them in a way that's actually sustainable for our planet. Thanks for watching The Explainer.